Good morning, everyone. I'm Andy, and today I would like to talk about reversing the life cycle, medusa transforming into polyps and cell transdifferentiation in the Teratopsis nutricula. Okay. So, what is a medusa? Medusa, they're also called jellyfish, and they usually live short lives, such as days to a few months. And they have a life cycle which includes sexual and asexual phase. This is a medusa's life cycle. You can see from an egg, it becomes a palma. Planula is like a ball, it can move to somewhere, then get settled. After they get settled, it becomes a polyp. And polyp grew out some buds. And the little medusa will come out from the black spots. Then it gets mature and die. So you can see here is the sexual phase and here is asexual phase. And they are between about 85 to 98% water. Although most of their bodies are water, they still have complicated structure. Here is the structure of medusa. Please pay attention to those with umbrellas. First, its umbrella. It's like an upper half of its bell. This area, we call it bell because it's shaped. Then radial canal and circular canal, which is also known as ring canal. Canals are relating digestion. And the polyp. I only point out two structures of polyp. One is endoderm. It also relating digestion. And the parasite. Parasite is like armor protecting polyp's body. So I want to talk about our end species, Teratopsis nutricula. They look like lighthouse. Yes, much better look like. And they're about 5 millimeters. It's like the nail they big. And they have special life cycle. How special? This is a typical medusa's life cycle. And the T can directly I'm gonna call my end species T in the rest of my talk. And T can directly turn into polyp from adult medusa. And because it's a condition which from old to young, so we call it reversal. Actually, this reversal can repeat and repeat forever, so you won't die. And this is what we want to study. For study this, we have three main questions. One, in which case will you reverse? Or how to make them reverse before they get old? Because we know they reverse when they get old. And what is the specific process of the reversal? And which part is used to control the reversal? For each question, we design an experiment for it. In which case, we do environmental stress tests, such as higher temperature or something, and the specific process we just observe with the microscope. Then which part we just cut and rear the tissues independently. And preparing. About 4,000 teeth recalled in the Gulf of Nephilus here. The time is about June to October in 1993 and 1994. And they have been reared in 40 beakers, which is 500 milliliters, and each have 100 individuals at the 22 degree. Okay, for experiment 1, we have 4 groups: starving, temperature, salinity, and control group. Each group we have 10 newborn medusa. And for starving, we just give no food. Then temperature, we swiftly change to X degree, like this. Directly 1 degree, directly 2 degree. Okay. Then the salinity, we add pure water in it. And control group, we did nothing. And all these experiments are be done when they are young, because they reverse when they get old. And experiment 2, observation. We observe with a fluorescence microscope. You can get the picture like this. Although, we observe for the 3 stages to find the difference between them. To explain three stages, we have to say how do we define a Medusa stage. The answer is by tentacles, or amount of the tentacles. Here are the three stages: child stage, teenager stage, and adult stage. They are defined by tentacles. And the child stage means immature. Teenager stage means developing, and the adult stage is sexually mature. So here are three stages. Experiment 3, we isolate each part. Here are those parts, A to I. Just list them down. And you can see the structure we talked before. Yeah. And for all this part, there will be two results. One is successfully reversed, and the other one is dissociation, which means that. Okay, here comes our results. For starving in reverse, for temperature in reverse 2, it is about 5 degrees higher or lower. And the salinity is still reversed, is about 10% pure water. The salinity is 33 PSU, and control group did not reverse. But it's still reversed after they get mature. Okay, here is what we got in our result in our experiment 2. And how about 3 stage? Here are 3 stages. You can see this is child stage, and the teenager stage, and the adult stage. Yes. Let's see a clear version. This is child stage, and it regress, settle, transdifferentiation, and become the poly. Next time teacher asks me if I draw this myself, I say no. This is my pen. Okay, so this is teenager stage. You can see the difference between child and teenager stage is that teenager stage have an inversion, which means it turns itself inside out. And also, it spawn. So it won't waste any of its eggs or sperms. Here's adult stage. It's not. It's similar to the teenager stage. Okay. And about result 3, we have 4 parts successfully reversed. It's D, G, H, and I. Okay. You can notice that every part have its umbrella and canals at the same time. Remember, so we can get the formula, which is its umbrella plus any canals equals success. Okay. Discussion. Why does it reverse when facing stress? It's like a mechanism. And it also can maximize the probability for surviving through a sexual regeneration or sexual duration, because they will spawn. And I want to introduce you a new concept. It's here. Remember this image? This stuff, we call it the cyst. The cyst. And the cyst has a special power. It has high resistance to the environmental stress. For example, it can stand 40 degrees for 3 months, and the normal condition is 22 degrees. It takes 3 days to become the poly. But after it stands 40 degrees for 3 months, it can still become the poly. So it has very high resistance to the environmental stress. And we can say the reverse is very useful to face this stress. Here is the cyst, and the cyst becomes a poly. Okay. Okay. Then why is that it only success when including those structures? Oh, and because its umbrella will become the parasite, which is the armor of polyp, and the circular canal or radial canals will become the endoderm of the polyp. Good. Okay, will it die? No, but just no natural death, which means it will not die. It will not die with aging, but it still die in many conditions, like being eaten or disease. Conclusion. The reversal of Turritopsis nutricula is confirmed to be a part of the life cycle. Confirmed. And for its reversal, its umbrella, circular, or radial canals are needed. Thank you, and Happy New Year.